Okay, so we've reached day 2 of solving quadratic inequalities, and I promised you today that we would be solving these quadratic inequalities using algebra. So that's going to be the focus of our learning goals today, will be algebraic methods to solve quadratic inequalities. So let's take a look at our first example. So it says to solve the inequality x squared minus 10x plus 18 is less than or equal to negative 3. Now if we had decided to use the graphing method, we would have put x squared minus 10x plus 18 in our graphing calculator and y1. And then we put in y sub 2, we'd put negative 3, and then we'd sort of just interpret based on the inequality sign whether we had a conjunction or disjunction, and we'd write our inequality based on whether we had a connected piece of the graph that satisfied, or if we had two separate branches that we had to write with a disjunction. But today we're going to be using algebraic methods, and so our first step to solving something like this algebraically would be to write the related equation. In other words, we just drop the inequality and we pretend like all along that this was an equation. So we'd say it equals negative 3 instead of being less than or equal to negative 3. So basically what we're going to be able to do with this equation is find those critical values, because that's actually what we were doing when we found the critical values with the calculator, is we were seeing what the places, those two places were where the parabola crossed the horizontal line, which is the solution. And so that's what we're going to do here. We're going to solve this like it's just a regular quadratic equality, and the values that we get for x will be those critical spots, the part that divides the place where the solutions are from where the non-solutions are. So how would we solve this? Well, the first thing we want to do is get everything on the same side, because when we solve quadratics, we want to have everything on one side and 0 on the other. So that means what I'm going to have to do is add 3 to both sides so that it leaves me with 0 on that one side. And so over here, when I add my like terms, I get 21. And so x squared minus 10x plus 21 equals 0. So now all I have to do is factor. Now if you use AC method, that's fine. A times c would be 21. So we think of factors of 21 that add up to negative 10. And I can think of negative 7 and negative 3. And so we rewrite that middle term as minus 7x minus 3x, or vice versa, and then plus 21. So we wrote that as a 4-term polynomial so that we could then split it up and factor by grouping. So the first pair, I can take out the GCF of x, and I get x minus 7. And out of the second pair, I can take out a negative 3, because if the leading term is negative, we always want to factor that negative out. And that's going to leave me with an x minus 7. And so I see a common binomial factor, so that means my final factored form would be x minus 3 and that common binomial of x minus 7. And that means the solutions are x is 3, which is the one that makes this one equal to 0, and the other one would be x equals 7. And that's what makes this one equal to 0. So these are my critical values. So these are the things I've been talking about, and what I could find in the table in the prior examples. These are my critical values, my CVs. So what I do then is I take those values and I create this number line, and I put these points on it, these critical values. So this number line, it looks like the 3 would be right about in here, and the 7 would be right about in here. And so I know that's also a critical value. And so I know the solutions are either between these two key points, or they're outside of this. So they're either the region between them or the regions outside of them, just depending on whether it's conjunction or disjunction. So one way I can tell is just looking at the inequality sign and knowing that this one says less than or equal to. And so that tells me the and part means it's a conjunction. But to be sure, it might be a good idea to actually test a point. So that's usually what I do is I'll pick one of the points, and I usually pick a point between the two critical values. Like say maybe I might pick 4. And I might test this point, so I'm going to test 4. So I'm going to test x equals 4, so I'm going to plug 4 in to the inequality up here. And I'm going to see if it makes it true. If it does, then I'm going to shade between 3 and 7 because that's where 4 lies, and then I'll know it's a conjunction. And if it doesn't make it correct, then I'm going to have to shade outside, and then I know it's two separate regions and it's a disjunction. So I'm going to go ahead and plug 4 in and see what I get. So let's see. 4 squared minus 10 times 4 plus 18. And I want to know, is it less than or equal to -3? Well, I found out that gives me -6 is less than or equal to -3, which this is true. That's a true statement. And so I know that that means the shading is going to lie right in between these two critical values. So I'm going to shade right between them. And then I know to write my inequality, it's going to be a compound inequality. So I put the x in the middle, I put the upper bound on the right, the lower bound on the left, and I just use the same inequalities from my original. They're going to be or equal to ones. So x is greater than or equal to 3, but less than or equal to 7. And that is my solution. And so basically I used algebra to find these critical values rather than using the graphing calculator. And just one quick note. Notice I used solid dots to represent the critical values on the number line, and that was because it was an inequality that was an or equal to also. So let's turn the page and look at another example. Okay, so we're going to go through those same steps to solve x squared minus 6x plus 10 is greater than or equal to 20. So remember that first step was to write the associated equality. And so in other words, we just replaced the inequality sign with an equal sign. And we solve that equation to find out what the critical values are. Oops. And so how we would solve this is by getting everything on the one side and 0 on the other. So I could do that by subtracting 2 from both sides. And then rewriting my quadratic. And let's see if I can factor this. So I'm looking for factors. They have to multiply to give me 8 and add to give me -6. And I thought of 2 right away. I'm not going to use the ACI on this one. I decided to just use the easy method because I know the factors have to multiply to 8 and add to -6. So I thought of -4 and -2 because they multiply to a +8 and add to a -6. And so I know the critical values are the solutions to this. And so what makes this first binomial equal to 0 would be a 4. And the second one is a 2. So my critical values are 4 and 2. And so I'm going to go ahead and put these points on a number line. So I'm going to put the critical values at 2. And I'm going to use solid dots again because these are or equal to. Otherwise I'd use open dots. And now I'm going to test a point. So I'm going to pick a point, and I like to test points between. So I'm going to test 3. And the reason why I want to test 3 is because 3 is the easiest number. It's the only integer between 2 and 4. And so I decided to plug 3 in. So let's see. If I plug 3 in, I'm going to go over here to the left-hand margin and plug 3 in. 3 squared minus 6 times 3 plus 10. And I want to know if this is a true statement that it's greater than or equal to 2. Well, that's 9 minus 18 plus 10. And I'm saying that's greater than or equal to 2, but as that turns out, that's actually saying that 1, because 9 minus 18 is -9, plus 10 is +1, so it's saying 1 is greater than or equal to 2, and that's false. So I don't want to shade between, I actually want to shade outside, and so I'm going to go up here, and I'm going to shade to the left of the 2, and to the right of the 4. And that means my solution set is going to be an inequality, that's two separate inequalities. It's going to be two inequalities that describe those shaded regions. The first one will be x is less than or equal to 2, and the other one is x is greater than or equal to 4. And that's a disjunction, and that's my solution set. And any values I pick out in either one of those regions, whether it be I pick like, say, 0 in this left-hand solution set region, or if I picked, say, 5, and put either one of those in to the original inequality, it's going to make it true. Okay, so that's the way we solve them algebraically, is we make it into an equation, we solve that equation to find the critical values, we test a point, and when I do is I always test a point between the critical values. If it works, shade between them. If it doesn't, shade outside of them, and then it will be a disjunction, as in this case. Okay, so we have one last thing to complete before we meet again, and that's the check for understanding for lesson 5-7. And so we're going to actually, I'm going to have you complete this as a you try, and it's more than one question, so it's a you try set of questions. I ask you to kind of, see if you have a pretty good handle on both parts of lesson 5-7. Question number 1 wants you to graph the quadratic inequality by, solve it by graphing. And just follow those steps there, A through F, and then questions 2 and 3 ask you to solve each of these inequalities using algebra, which is the method that we did today. So basically the U tries 2 and 3 are U tries for the method that we just learned today. So if you'll complete these questions as U try questions, and we will actually, when we meet in class, we'll go over what the answers should be. So go ahead and try the U tries, and I'll see you in class.